So a dispersing element plus the collimator will make a monochromator, right? Monochromator. Why do we call it a monochromator? Because the function of the collimator is first of all to make the radiations parallel, okay? And then the function of the dispersing element is to select only one wavelength. So overall, this collimator plus this dispersing element together, they together help us in selecting a monochromatic or a single wavelength radiation. Okay, single wavelength radiation. So how does a monochromator work? See, let's take the example of a prism monochromator where the dispersing element is a prism. What happens is, for example, we have, this is our source of radiation, okay? This is our source of radiation. Then from this source of radiation, there is an entry slit, okay? An entry slit. Radiations enter through this entry slit. Like this, okay? Then we have a lens. What does the lens do? It collimates the radiations, okay? Makes them parallel, okay? Then we have a prism. This is the dispersing element, okay? What does it do? It breaks this radiation into its constituent wavelengths, okay? Into its constituent wavelengths. Let's say they are lambda 1 and lambda 2. Lambda 1 and lambda 2, because it comes from the same source, so it will be broken into its constituent radiations in the same way, because these are all actually the same radiations. So lambda 1 and lambda 2, lambda 1 and lambda 2. Then we have one more lens, okay? So what does this lens do now? It again converges the radiations, right? It will converge the radiations like this, and this one, these will again converge and form what? Lambda 1. Similarly, these two will be converged and form what? Lambda 2. Now, then we have an exit slit, right? Exit slit. The placement of this exit slit is very important. We'll place this exit slit, we call it an exit slit. We place this exit slit in a way that only lambda 1 can pass through it. See, it's placed in a way that it has blocked the passage of lambda 2, right? So only lambda 1 will pass through this and will obtain a monochromatic radiation having wavelength lambda 1. This is the working of a monochromator. Then this wavelength or this radiation will enter into the sample, right? Having an intensity I naught, and then we'll get a radiation, the transmitted radiation of intensity I, which will then go to the detector, right? This is how the monochromator works.